Hi again, everybody. Trying to illustrate the point of how to understand to read schematics. I think for beginners, and I've been asked this quite often, I guess recently, the best way is for beginners, and there are a lot of them from what I see in the viewers. Instead of going to the component one, this is the component one. It's a little confusing at first. So let's say I have a fuel pump problem with GMs, and most of them are alike. There's another thing that I was saying before. It's called the power distribution, which is this one, power distribution. Again, which ones do I use? I love Mitchell. I love Mitchell for the reason that they tell you the terminals, that they tell you also the pin numbers. So you see over here, this is relay. This is going to pin 3. This is a computer. It tells you it's going to pin 21. Now, it gives you the information where these are located. Where sometimes, especially the computers and all that, it tells you where it is. Like this one, body, relay block. That's very helpful. Now, the other ones, all data, pro demand, they have the lines that you highlight and it tells you everything that's connected to it. The point that I was trying to make is that's fine and it helps you a lot. You don't have to go tracing over the whole thing. But problem is you have to know how the components work. It's not enough just to see the traces. You have to know how a relay works. What turns it on? The computer might give a relay a B plus, might give it a ground. It might be an input, might be an output, might be 12 volts, might be 5 volts. These are not illustrated on those type of diagrams, all data and all these things. Not even on this one. I put it in myself, as you can see. So if this is and you'll see what I'm talking about when I illustrate it. This is a relay for a fuel pump. You have to know how it works. You have to know which is the load side, which is the control side, which is being turned on. You have to know, is the input to the relay or is the relay an output? Especially with computers, you have to understand which one is the input, which is the output. Fuel injectors, they have the grounds are by the computer. You have to know, is it an output, is it a computer? So it's just more than just highlighted traces. You have to understand how they work. And this is why I've been teaching the way I've been teaching. So you understand the foundation. And hopefully you'll understand it and we'll go over hands-on very, very, very soon, I hope. And you'll understand everything. Now, get to my point. If we go this way, first we look for the fuel pump. Here's the fuel pump. Right here, right in the tank. This is the symbol for a fuel pump. Now, whenever you think of fuel pump, think of two things. Automatic thing. The computer and the relay. Think of those things besides the fuse. Those should come to you automatic. Whenever there's a fuel pump problem, first thing that should go into your head besides fuel pressure is fuel relay. Where's the fuel pump relay? Where is it? Where is it? Number 2, does the computer control the fuel pump relay? These 3 thoughts have to come into your mind right away. Because these are computerized, electronic, automotive. This is what I've been saying. This is not 25 years ago. You cannot understand diagrams from 25 years ago. This is on a higher level. Okay, now the pump goes to this. If we look at this fuse, and I'll go to the block diagram that I was referring to. If you look at this fuse, it means hot at all times. What does that mean? That means regardless if I have the key on or key off, this fuse will always measure 12 volts here and 12 volts here. Because it's connected to the battery, not through an ignition switch. It goes directly. So therefore, regardless if I have the ignition switch, whatever position, doesn't matter. I will measure 12 volts here, 12 volts there on the other side. Does that mean that I have current flowing? This is the mistake that many mechanics make. No. If this fuel pump, this relay is not active, I do not have current flowing. But what do I have? I have 12 volts here and 12 volts here. What will it tell me? It'll just tell me if the fuse is blown. Until you turn on the pump, until you turn on the relay by the computer. Then, this is why I teach current. You can have voltage at 2 points, doesn't mean you have current. Again, you don't even have to have the key here. Hot at all times. I don't even have to have the key. I go to the fuse, you'll measure 12 volts instantly. Unless it is blown at both sides. So, now, what turns on this relay? We said the computer, right? Now, if you look at it, look at the orange, and I took the opportunity, it's called the fuel pump relay. There's a VCM, a vehicle control module, and a power control module, depending on 2.0 or 4.3 liter in GMs. This is the input or the control line to turn on the relay. So it gives it 12 volts. If it gives it 12 volts here, where? To pin 2. That means the other side, which is pin 1, is ground. Fine. Now we have something to turn on the relay. What's the other question? What turned on the computer? In order for the computer to turn on the relay, we need first B plus to go to the computer in the first place. comes this green line through this VCM pin 21. That's again the computer, vehicle control module, pin 21. That's the B plus for it. That's where it gets the voltage from this fuse to turn on the computer. First you turn on the computer, then the computer says, okay, what do you need from me? I need you to turn on the fuel pump relay. Computer says, okay, I'll respond to your request. Boom, here comes this line. Here, okay, I will give you 12 volts for the relay. Fine, I will acknowledge you. If you do not have the 12 volts going to the computer cannot activate this. You will not turn on the fuel pump, among other things. So when you turn on and there's and the engine's not turning over, and you see the check engine light, you know somehow that the computer is being activated. It's getting 12 volts. Now, when that happens, when we see one point from other illustrations, even though you have the traces on all data and pro demand and all these things and Haynes, they're great wiring diagrams. Would you know that this is an input from here? Would you know that? Would you know that this is going to the input of the B plus of the computer? You would just see the traces, the highlighted lines. You have to know how they work. This is on a different level that I have not seen too many people in this field that I've worked with on a level like this. So anyway, once this is activated, boom, the dotted line means that this is pulled in. Now you see the orange line? Now current can flow. It flowed this way. Now the other path, it can flow through pin 3, through here, and guess where? To the fuel pump, in the fuel tank. Now, if that's too difficult, and I think it would be difficult, for beginners, go to the block diagram. Start from here. Look for the fuel pump relay. This will be much easier for beginners, and you'll see why. This is connected to the battery. Okay? ECM fuse, 20 amps. If that sounds familiar, it should. Because you know what? We just had it right here. In the component level, this is the same fuse, 20 amps. Where does that fuse feed? Well, what did we say? It feeds the fuel pump relay at pin 3. Is that true? Let's go to the component level. Right here. And here is right here. It feeds pin 3 of the fuel pump relay. Okay. What else? Well, it feeds this one, and also at the same time, depending if you have 2.2 liter or 4.3 liter, it's going to the module, the computer. Which pin? Pin 21. Which connector? C3. So therefore, this fuse is feeding the fuel pump relay, but also is giving B plus to the computer to turn on the computer. Let's go to that one. Let's see. when we spoke about it before. We said one side goes to the fuel pump relay at 3, and the other side, follow the green, goes to pin 21 of the computer. Pin 21 of the computer. It is right here. So this is much more easier and simplified for the beginner to look at than going through this. That's why I recommend first find this, see where this is very easily, if this fuse is blown, what do I lose? I lose the relay and I lose the computer. No computer, no relay. This controls this. I'm going to continue on for ignition. And please see my channel, Joe Electronic Schematics for Auto. You'll see so many videos, and like I said, I'm trying to hit my goal, watch time. Please try to help me out with that. Thank you, and I'll go to the next one.